Hello, here's a cool little surface integration problem that someone, I think it was Mark Zhang, I hope I didn't get your name wrong. If I did, I'll go over and edit in a voiceover to fix it. Um, yeah, posted this cool little surface integration question in the group me, and I thought that I would go through it because I worked through it myself and made a really dumb mistake the first time, but figured it out, and it actually has a pretty cool solution. So we see that we're just taking a normal surface integral here. This is a flux integral because it's in the form f dot ds. And we are given our f. We can write f as 1 y squared negative 1 minus z minus x squared. And we see that we're looking at the intersection with this part of the plane and the unit cylinder oriented on the z-axis. So the reason that I'm actually recording this question is that it involves kind of a leap in logic that you have to do with some of these, especially Stokes' theorem questions. But it's interesting that it's showing up here, and it's a good showcase of kind of the really weird things you have to think to do in some of these questions. So the first thing that you have to identify is what's the problem with just evaluating this normally. We know our normal vector. If you're used to these questions, you know that if we're given a plane intersecting a cylinder, our normal vector is just going to be, well, it's not a, there we go. Our normal vector is just going to be 1, 1, 1 because we're oriented upwards, and the coefficients of our plane here are going to be our normal vector. So that's no problem. We could take this dot product, f dot, because remember, we can rewrite this as double integral over s of f dot n ds. But we have an issue here, and I hope you can see our issue, is that this thing is enormous and terrible, and we really don't want to have to evaluate that. So what we can do is notice, and here's the leap that kind of takes a little getting used to. We can express this in terms of z. We can say z equals 1 minus x minus y, and then we can substitute this in for our z here. So f is going to become 1 y squared negative 1 minus 1 plus x plus y minus x squared. And this is going to evaluate to 1 y squared, and let's see, we're going to cancel here, and we're left with negative y squared. And so this is perfect because now when we do n dot f, or f dot n as we have it written up here, we are going to get 1 plus y squared minus y squared. And so now all we're left with is a double integral over s of 1 ds. And we know that we can express this as the double integral over the xy projection of this area, and whenever we are in the unit cylinder, that's just going to be the integral from 0 to 1 and the integral from 0 to 2 pi of r dr d theta, and then whatever we had in this integrand, which is just 1. So evaluating this, we're going to get r squared over 2 on 0 to 1, which is 1/2, and evaluating this on 0 to 2 pi d theta, we get pi. Okay, hope that was helpful. I don't know where I'm going to put this video. I might just leave it unlisted and link it to the group chat. Hopefully I can get it up in like 10 minutes though. See ya.